Hello, sixth grade. I'm going to be recording our lesson today for these next 2 weeks. But before we begin our lesson, let us begin with prayer. En el nombre del Padre, y del Hijo, del Espíritu Santo. Amen. Offer up your own special intentions. And my special intention is that we all are safe and well, and we make it through this little crisis that we have. Dios te salve María, llena eres de gracia. El Señor es contigo. Bendita tú eres entre todas las mujeres, y bendito es el fruto de tu vientre Jesús. Santa María, Madre de Dios, ruega por nosotros pecadores, ahora y en la hora de nuestra muerte. Amén. En el nombre del Padre, del Hijo, del Espíritu Santo. Amen. The lesson for these next 2 weeks are going to be solving more equations. We're going to go back to solving our equations. These are going to be a little bit more complex. So I'm going to be giving you about 7 to 8 examples that will cover the equations that you will be encountering these next 2 weeks. So if you have an issue, you can always replay the video, or you could send me an email, and I will be more than happy to help you. So let's start with the first one. We have 6x is equal to 4x plus 18. Now, in this equation, you want to look at where our variables are. Now, we have one variable on this side, one variable on the other side, on the right-hand side, but we also have a constant number. Since this term here does not have a constant number, it might be easier to move this 4x over here. You could move this 6x over here, but then you'd have to move the 18 over. So let's try to do it in one step versus 2. So in order to do this, you know we do the opposite operation. This is a positive 4x. We will subtract 4x from both sides. Line, reason, you all know, so they don't fall. All right, obviously these will cancel. We have our equation, and we have 6x minus 4x is 2x equals 18. Beautiful. One-step problem of multiplication. The opposite operation of multiplication is division. We'll divide by the coefficient, which is 2. Therefore, x equals 9. Remember that these 2's will simplify to 1. All right, that's your first example there. Let's look at another example, similar but a little bit different. 3y is equal to 15 minus 2y. Again, looking at that problem and this one, we have a term, and then a constant number. Since our terms are over here, we're going to move this negative 2y over to the left-hand side. All right? Opposite operation of a negative 2y is a positive 2y, so we're going to add 2y to both sides. Negative 2y, positive 2y cancel. We have our equation sign. We have 15 on the right-hand side. Left-hand side, 3y plus 2y is 5y. We've got it down to a one step. We'll divide by the coefficient, which is 5. Therefore, y equals 3. Remember that these do simplify to 1. All right? Now, on our next example, we have a fraction. I know you all love fractions. Let's not make it that difficult. All right. On this one, as you can see, I've switched it around so you can see the difference with the locations of the variables. We have our single variable over here, single term over here. This one is connected. So what I'm going to do is bring this 4/5 over to this side. So I'm going to subtract 4/5 x. Therefore, line, don't forget, these cancel. We're left with 3 is equal to, now we have a little bit of an issue here, a fraction. Remember that the coefficient of this variable is 1. So now, 1 minus 4/5, you should know that's going to be 1/5, all right? But in case you have an issue, I could rewrite this 1 as a fraction having the denominator of 5 as 5/5 x minus this 4/5 x. And that's where we have 1/5 x remaining. All right? Now, remember, In order to solve this, we're going to multiply by its reciprocal, both sides, all right? We'll multiply by 5 over 1. So everything you learned from before is coming back into play, all right? So we're going to simplify these. These simplify to 1. So we have x equals, remember 3, you can put 3 over 1. And that's 5 over 1 times 3 over 1. 3 times 5 is 15. So x equals 15. All right? All right, let's go on to our next one. Our next example, a little bit more complex, but still not that difficult. 8 plus x over 9 equals x. Notice now we have a fraction, not only one term in the numerator, but we have a binomial. We call it a binomial, 2 terms. Okay, not difficult. The situation here that we have is that we have a fraction with a denominator of 9. So what I want to do here is get rid of that. And the way I've taught you, and if you remember, we're going to multiply by this reciprocal of, in this case, we have like a 1 over 9. So it's going to be a reciprocal of 9 over 1 we're going to multiply by. This will simplify these 9s to 1. Now all we have left is the 8 plus x equals, now here's where you have to be very careful. This is like x over 1 times 9 over 1. X times 9 is simply 9x. Now we've made it like one of the other problems. We've taken away that fraction and we've made it into a 2-step problem. Since our x's are on the right-hand side this time, and we have a term and a number, we're going to subtract x. We're going to bring it over to the right-hand side. These will cancel. We have 8 is equal to 9x minus x, or it's a 1x, so understood 1. So that's going to give you 8x. Well, that's going to be simple. We divide by the coefficient of 8, so x will equal 1. These simplify, all right? So notice that in this case, we want to eliminate the fraction. It makes it a lot easier for us, and we multiply by that common denominator of 9. All right, let's move on to another one here. All right, our next problem we have is this one. 7 times the quantity a minus 2 minus 6 equals 2a plus 8 plus a. A little bit more complex, more terms. The first thing you want to do is let's get rid of these parentheses. Now, if you remember, maybe a couple weeks ago, when we were doing these, I introduced what we call the distributive property. All right? The distributive property. And that means you're going to take this number on the outside and multiply it by the 2 terms in the parenthesis by distributing the 7 over each term. So 7 times a is 7a. 7 times a negative 2. Don't forget that sign. Is a negative 14 minus the 6 equals the 2a plus 8 plus a. Now I'm doing it the long way here so you can see what I'm doing. Now, let's try to see if we can combine some terms. Well, I have a like term here of a negative 14 and a negative 6. Remember your signs. Numbers are the same sign. Add their absolute values together, take the common sign. So we're going to have 7a minus 20 is equal to, hey, 2a and a 1a. 2 apples plus 1 apple gives us 3 apples plus 8. Okay? Now, in this type of problem, be very careful. We have a 7a and a 3a. I've taught you that if you don't want to work with negatives, this is the procedure you want, but any procedure will work here. If you want to start to move the 7a over or the 3a over, it'll work either way. I'll show it to you. But in this case, look at the coefficient of each of the terms. Which one has the lesser absolute value? 3 does. So I'm going to move that number, that 3a, over to the left-hand side by subtracting 3a. This will cancel out. Look at your equal sign. Line it up. So 7a minus 3a is 4a minus the 20 equals 8. Now it's just a 2-step problem. Since the a's are on the left-hand side, I'm going to move the 20 over by adding 20 to both sides. 4a equals 28. One-step problem, division, divide by 4, a equals 7. And to check it, you can substitute 7 back into that and see if it works, and it does. Now, I did tell you I'm going to show you the other way, same problem, but I'm going to take it from here, all right? Same procedure, we're going to do it, but I'm going to take it from there. So 7a minus 20 is equal to 3a plus 8. I want to show you that it's going to work both ways. Now, this one we move the 3a over. This one I'm going to move the 7a over by subtracting 7a. Notice this will cancel. We have negative 20 now. Remember, bring the sign down. Equals 3a minus 7a. Be careful. Now we have a negative 4a plus 8. Our a is on the right-hand side. I'm going to move that 8 over by subtracting 8. Okay? So therefore, this cancels. Equal sign. I'm left with negative 4a equals negative 28. Now, the difference that you see here is there are no negatives here, negatives here. That's the reason. Either way will work. So I'm going to divide both sides by a negative 4. Here, simplifies to positive 1. I have a is equal to negative 28 divided by negative 4. Negative divided by negative is a positive. Positive 7. We get the same answer. So therefore, either way works, but if you want to eliminate the possibility of making an error with a negative, then always select the coefficient with a lesser absolute value. Choose that one to move it over. Okay, let's go to another example. Now, we're going to give you some examples here that you might encounter this week and possibly next week. Let's look at this problem. All right, this problem, again, similar to the one we just did, 3 times 1 minus r plus 5r is equal to 2 times r plus 1. All right, let's eliminate the parentheses by using the what property? I hope you said distributive. So 3 times 1 is 3. 3 times a negative r is a negative 3r plus 5r equals distributive. 2 times r is 2r. 2 times a positive 1, positive 2. Let's combine, because I have a negative 3r and a positive 5r. Numbers of the opposite sign, take the difference. The difference is going to be 2, and it's going to be positive because this one has a greater absolute value. So I have 3 plus 2r equals 2r plus 2. Now, we have to select a variable to move. You should notice here that I have 2r here, a positive 2r, and a positive 2r. If for some reason I subtract this 2r, what happens to these 2r's? They cancel. What happens to these? They cancel. What have we just lost? We've just lost our variable. We need a variable to solve. So actually you're left with 3 equals 2. And that's not a true statement. It does not. When your variables cancel like that, this problem is called a no solution problem. No solution. All right? Can't solve it. Variable's gone. All right? And it's an untrue statement. 3 does not equal 2. So if you encounter any of these problems as you're doing them, especially when you have the same term on the opposite side of the equal sign, same sign, not opposite sign, same sign, you know they're going to cancel, therefore it's a no solution. Now, on the flip side, I'm going to give you another example of another type of problem. We have 1/3 times 12x minus 21 is equal to 4x minus 7. All right? So, now, here we can do 1/3. 1/3 of 12. You should be able to cross simplify here. Greatest common factor is 3. That's going to leave us with 4x. If you don't know how we did that, it's 1/3 times the 12 over 1. Cross simplifying, you get 4x. Minus the same thing with 21 is going to give you 7 here, equals 4x minus 7. Now you should notice and see very carefully, what do you see? Hey, you see 4x minus 7 is equal to 4x minus 7. When the left-hand side and the right-hand side mirror each other. when they mirror, they're exactly the same. Positive 4x, negative 7, negative 7. This is called identity. Which means, really, it's not that it's no solution. It does have solutions. It's the solutions of all real numbers. And what do I mean by all real numbers? Is that any number I substitute in here will make this a true statement. Over there, 3 equals 2 won't. Here, if I was to do the subtraction and the addition, 0 would equal 0, and that's a true statement. So any number I substitute in for x, 1, 5, 1/2, 1/3, million, it'll always give me a true statement. So that one is called an identity. You'll encounter some of these this week, some of them next week, but at least you have your examples there. One last one, and I'd like for all of you to try this one as I'm going to put it up on the board, give you a few seconds to try it. So here we go. 3 plus 4 times a plus 2 is equal to 2a plus 3 times a plus 4. A few seconds, you should be asking yourself, okay, what do I need to do? I need to eliminate the parentheses by using the distributive property. Very good. So therefore, here we're going to bring down the 3. Some of you are going to try to combine this. You can't. Orders of operation tell us we've got to do multiplication before we add. So bring the 3 down. Now distribute, which is going to be plus 4a plus 8 is equal to, can't do anything with the 2a. Now we're going to distribute. 3 times a is 3a plus 12. Okay, distribute that. Now, combine. Let's bring it down to a term and a number, a term and a number. Well, I've got 2 similar terms here. 8 plus 3. So we're going to bring down the 4a plus 8 plus 3 is 11 equals, let's combine these two, 5a plus 12. Now, you look at both and say, we don't have identity, we don't have anything like that. All right, so we have our variables. I like to start with the variables myself. Which one has the lesser of the 2 coefficients? Obviously 4, so I'm going to move the 4 over so that way I don't have to worry about working with the negative. Sometimes you have to, sometimes you won't. Cancel, this becomes 11 equals 5a minus 4a is simply a. You want to put a 1, that's fine. You shouldn't have to anymore. Plus 12. Now remember, the a's are here. Some of you want to move that 11 over. Can't, because we got to have a number on each side of the equal sign. So therefore, I'm going to have to subtract 12. This cancels. A is equal to, now be careful with your signs, negative 1. All right, that concludes the examples on these problems. Please make sure that you check, all right, as you're going through, step by step. Take your time. Again, I've given you the examples, but if you do have a question, all right, on a certain problem, you can email me. I think all of you have my email, hrodriguez, and that's an R, UEZ at sbdiocese.org. Make sure it's org and not com, all right? So that way I get it. And I can help you. Don't email me to get an answer. Email me and show all work. You can't do that in 1 or 2 steps. Notice it takes 3 to 4 steps to solve these, all right? Wishing you all a great week or 2 weeks. I'll be in contact with you. Again, if you have any questions, email me. Thank you very much, and have a good one.